Welcome to, this is the third speaker. You're our third event of this series. Glad to have you with us.
Thanks.
We've had several different manufacturing and engineering realms. This is our first strictly software person, so this will be cool and new for everybody. The breakdown for everybody to follow along is as follows. We have welcome introductions, and follow that we have Mr. White's questions, then general remarks from the speaker, and then prepared students. For those in the audience, Lily and I know each other, but that Lily, this is more for your benefit. Our conversation will be more halting and hesitant because I'm writing things down, not because of it.
No worries at all. That's great.
So yeah, why don't you go ahead and introduce yourself, what you do, why you do it, and sort of your pathway into doing what you do.
Sure. So I work at Purdue. My role is what's called a application developer here, but it's basically software development. Depending on where you work, there's a lot of different titles for it. So software developer, full stack developer, application stuff. So it's all kind of the same. It's just titles. I got interested in software because as a kid, I was always kind of the one in my family responsible for the technology. So back when DVD players were brand new, or using floppy disks or USB drives, that was my job, to set my family up with all of that stuff. I never had a computer science or coding class in high school, but when I got to college, my mom was like, maybe you should try a computer class. You were always good at that. And I fell in love with solving problems really quickly and realized that software was something that would blend my abilities in different STEM disciplines and still solve cool problems and make an impact for people. So I went to school and got my bachelor's in computer science at Brigham Young University. And then this is my first job out of school working at Purdue. I've been here about 2.5 years, and yeah, I really like it.
Awesome. Can you describe what you do at Purdue? Like what does full stack application, what does that mean specifically at Purdue?
Sure. So I actually at Purdue, I work on a team that's called informatics, and we are specialized in instructional technology. So as students, you guys know probably a lot more this year that you have online homework or educational tools. So my team, what we do is build those tools for Purdue, so at a little bit of a higher level. And so our job is to kind of gather all of this information about things that students or faculty or support staff need, and then build a tool that will help fill that need that instructors can use in their classroom. So day to day, it means that I'm working with instructors and coding up new features on tools that we have. Does that make sense?
Yes. Yes, does it make Liam? Does it make sense for you? Okay, Liam's our spokesperson for the students. Okay, so I'm gonna get into some of my prepared questions. These are different from the ones that I sent you. Yeah, give you a nice little flash. Not there.
Okay.
So you talked a bit about your high school / family upbringing with setting up the newly acquired DVDs, players, and troubleshooting with floppy disks and whatnot. So I think really fast, can can you explain the difference between hardware and software, like why you fell in love with software versus the hardware, which is what I would assume to be the DVD setting things up kind of thing.
Yeah. So that was just kind of my introduction into computers. Was when those things first came into our home. Of course, you all grew up with those things already. But hardware is the electrical components that create a computer that have the ability to do logic because of the way that electronics work. Software is what is the programming language, or is the programming layer of abstraction that is kind of in between what the hardware is built to do and what the user needs to do. So it's kind of the in between. So some software is going to end up with an interface that you use on a screen. So things like apps on your phone, or when you go open a tab in your browser on your computer. Sometimes software is the layer that you don't necessarily see. So things like an Alexa, there's software in there to be able to translate your voice into the electronic code, the ones and zeros binary that the hardware needs to actually use a speaker and answer your question. So it's just the layer of abstraction between the device itself and what you as the end user need. It's like a translator, kind of.
Perfect. So the first, I guess, prepared question, what was encouraging to you in specifically your high school and family background during still the high school age? What was encouraging for you to explore this career path? And at the same time, what was discouraging or maybe obstacles that you faced?
Yeah, so some encouraging things. I went to a small high school, smaller than Jefferson is. So there weren't a whole lot of extracurriculars, but I also had really good teachers that would encourage me to maybe go above and beyond on a project. So I remember like making really elaborate PowerPoints and just being excited about animating little things. And so things like that got me used to using a computer and get me to start thinking about maybe there's a better way I could solve this problem. Could I do something in Excel that would make this, assignment easier for me to do? So that's something that I think was good, that I had good instructors who were able to see that and let me kind of explore different pieces of software. Some discouraging things, I think I mentioned I didn't have a computer science class. I didn't know what programming was. I didn't know that there was such a thing as binary until I was a freshman in college. So that was hard in the sense that I felt like a lot of my peers at college had experience with this already. But the truth is that you can catch up really quickly. So if you have the opportunity at Jeff and you're interested in learning more about web development, or, take a yearbooks class, or I'm sure Josh's class is helpful for this kind of thing too, to explore your extracurriculars, because not everybody has them. So.
For sure. You're talking about the encouragement to go above and beyond in different projects via different applications, things like that. I remember, so my dad was a biology teacher. He was everybody's freshman biology teacher. And he had this project where you had to make up an island. You crash landed on an island, and you had to mesh different, the story doesn't matter. You had to mesh different animals. Anyway, and I remember being really into the animation of PowerPoint then, and that doing a lot for me. And yeah, I still like exploring the animation side on PowerPoint because of that class. And like, it's one of the things that I remember about biology class. Like, everybody remembers mitochondria as the powerhouse of the cell, but
Yeah. I remember I had a class that was supposed to be a computer class, but it was really just like a typing class. I think it was my freshman year of high school, and we had to make a PowerPoint about our dream vacation. And I got really excited about a skiing vacation, and I made this little mountain, and there was this skier that would move as you went through the presentation. Anyway, just goofy stuff like that that I totally nerded out on. But it was a good way to explore what technology could do.
Yeah, for sure. So now that you are in the technology world, and maybe let's have this be like a tiered question. So in college, now that you are in your major, how have your perceptions been affirmed or changed? And then once you got your job at Purdue, how did, again, those perceptions that you had about that world change or affirm?
Yeah, so when I first started computer science, I remember the first class being overwhelming just because I didn't have a whole lot of background. I remember at the beginning, I was concerned it was all going to be ones and zeros. That's all that I knew. But you don't learn about binary until a couple classes after that. But things like writing in my first programming language, like I didn't know that those things existed or that there was more than one programming language. So that was just kind of like a free fall of information because I didn't have enough context about things. But as you go on, like you catch up really quickly and you start understanding the layers of abstraction, and so that's really helpful. And so by the end of my degree, I felt like I had a pretty good sense of, this is what computer science is, and this is how you build good software. And every company is going to want to build good software all the time. And then you get into the real world and you realize that not every developer is a good developer, and that sometimes companies have different priorities and you don't always build the right thing for the right reasons, or you take shortcuts. And so you just kind of I had this second realization of, sometimes you don't have the resources to go above and beyond on something. You just need to get it workable so it can get out the door. So sometimes we talk about something being 90% done, and that's enough, and being able to get it to the customer so that they can use it. And that was kind of hard to let go of being a perfectionist kind of and wanting to get it just right. But yeah, you make compromises in the real world.
Yeah. I'm seeing weird things in the screen. You've talked about layer of abstraction a couple of times, and I think the word abstract, I'm trying to think of examples of where students may have seen it. So what I'm thinking of is Inside Out, and you go through the layers of abstraction and dimension and things like that. You become more abstract. What does layers of abstraction mean?
Yeah, so a really primitive example is if you think about shapes. So a triangle and a square are both shapes, and they both have sides. They just have different numbers of sides, right? So the individual shapes, the triangle and the square, are one layer of abstraction, and then the next layer up it's just a shape. And being able to kind of understand a problem and break it into smaller parts and figure out what things have in common and how you can abstract it up a layer. So a lot of times you have things that have a lot of commonalities between them, and you just have to, when you are able to abstract up a layer, then you don't have to repeat yourself over and over again, because in code you have to give the computer instructions for everything. if you have to give the computer instructions for how to build a square and how to build a triangle, it's easier to give instructions about how to build a shape and then how to build the different kinds of shapes.
I love that. That was
So
perfect.
that's a simple example.
Awesome. Thank you. I know that my high school teacher would probably be kicking himself. We had a couple of different phrases in the classroom, and one of them was not a good one, but as in the phrase was good enough. Like we would be done with the project and we would say good enough, and our teacher would say, no, that's not something that you should ever attain towards good enough. But what does how does a perfectionist fit into a good enough world? Does that question make sense?
Yeah, sure. So I think it takes practice and time. But I think a lot of it comes from being able to communicate with the other parties involved, and understanding their expectations. So we have people at Purdue that are let me think. So it's important to them that we deliver something on time and on budget. And it's important to the developers that we build something that's a high quality product. And so you have to kind of make this negotiation of which things are more important and when. And when you realize that it's not a reflection of you as a person or your talent as in whatever position you're in, whether you're a developer or not, but being able to know when you should make those compromises and when the risk is actually low, and it's okay to deliver something 90% done if the risk of the 10% is low, if it's not going to cause a problem very often. So it's just kind of this negotiation you make with yourself, and as you understand better the needs of the people who are depending on what you're building.
For sure. For sure. I'm going to go back and sort of go back through the progression phase. So before full-time employment and within your college years, you did a mission trip to Brazil. In what ways has that educated your professional career? As in
Sure.
talking with, or obviously speaking another language, but like interacting with different cultures, and what does that do in a, I mean, Purdue, the student population is very diverse, and so how does that help that world?
Sure. So I lived in Brazil for about 9 months. And learning a new language is hard, just like learning a new programming language is hard. There's actually a lot of parallels there. But one of the advantages of living abroad and to talking to people who are very different than me was, learning to really listen to people, especially when you don't always understand, and practicing those communication skills. There's this perception that if you know how to code or to program, then that's all you need to know to be a good software developer, but you really need to know how to talk to people about technical problems in a way that they're going to understand. So practicing communication was really important. And then also something within the software industry itself is that it is becoming more and more diverse. As you have people who are from all over the world on your team, it can be really important that you are a little more patient with your colleague who's from India who has a thicker accent. Like, you just have to take the time to make sure that you're valuing them and their input, because they're really smart people, but you have to slow down a little bit sometimes to be able to get to be on the same level of understanding about things. So I had an internship, for example, where my manager was a gentleman from India, and it took a really long time for me to get used to his accent. But Brazil helped prepare me for that because I knew what it was like to be on the other side of someone else not understanding my accent. So not just Purdue being diverse, but also the people I work with come from all over.
For sure, for sure. Sofia Vergara, the Latina actress, she once said she was having issues speaking in English on like a talk show, I believe, and the crowd was like giving her a hard time or something. I don't remember the context, but she said, "Oh, shut up! I'm very smart in Spanish," and I think that that is a fun reminder that intelligence isn't language in a sense. So yeah. So now that you are in the tech community, how do you find support within that tech community as a woman in technology, but also outside of that context? Like, I imagine software development is very hard in and of itself. So, and how does your work team fit into your support network?
That's a good question. So I'm really lucky. I love my team, and I think that they are a huge support. We have a variety of skill levels, and everybody has a different background and experiences, and because of our team culture, I suppose, like, we're always really supportive of if someone needs help with something, there's always a person available. And also, we're a group of people that are really excited about trying new things and new technologies. So they're good about kind of trying to keep us all up to date on all the new things. Software changes really quickly. You don't get a degree and then you're done. You have to learn every year about the different things that are changing, and the way that web development works or programming languages. So having a good team is a really important part of my support network. As far as being a woman in technology, I think an important thing is finding a mentor, finding someone that you can talk to about when you have challenges. I've been lucky that I don't feel like I've faced a lot of those challenges. I just have always kind of been able to stand up for myself when I needed to. But at the same time, I have a female colleague that it's just really good to be able to bounce things off of her when I see something that is maybe not the way that I think it should be. So having, people you trust is important, whether they work with you every day or whether it's someone you meet at school. That's important. Also, the development community has all kinds of resources online. There's tons of groups and Slack groups and LinkedIn groups and Stack Overflow, that you have so many options to collaborate with people online if that's what you want to do.
So you brought up Stack Overflow, and there's the outsider perception that software engineering is copy and paste, right? So how much have you seen? How much is the fake it till you make it mentality true within? So you mentioned having internship experiences as well. So within the different industries of education versus otherwise.
Yeah, so Stack Overflow is an awesome resource in that you ask questions and everyone asks questions and gets answers, and so that's to our advantage of being able to Google something. We joke that a good developer is really just a good Googler. Like, you just really have to know how to comb the internet to find the answer to your question quickly, so that you don't get stuck on something. But at the same time, like in the real world, you can't copy and paste poses risks. You run into copyright problems, intellectual property. Like the risk of copy and paste is really high. And if you copy and paste, you're more likely to introduce bugs you didn't know about because you didn't understand the code you were looking at. That's something we see a lot, you know, in students at Purdue, not just when I went to school, of you turn in a computer science homework assignment that you copy and pasted, and then you're not going to know what's going on when you have to take an exam. So there's consequences to that. I think it's going to vary by industry and by developer, but I think for the most part, any developer worth their salt isn't going to be a copy paster.
Good deal. Good deal. So takeaway. So I have one more question. But takeaways that I got, just to sort of summarize, as an educator, is encouraged to go above and beyond. Make sure that there are outlets for that sort of creative problem-solving outlet. Get used to create. I don't know, and I wasn't able to write it because I don't know how to say it. But create adaptive moments. So things that will drive more focused or more evolving change, because you said the industry changes constantly and you need to be continuing to learn new syntax, new languages, things like that. Would you have any other advice for educators? So not students anymore.
You know, I think those are two really, really good things of making sure there's opportunities to be creative and to use computers to solve problems. I think learning to break a problem down into smaller pieces is also a great skill that that you need pretty desperately when you start trying to build something complicated. So being able to learn to break things down into smaller pieces, and that opportunity to adapt is really important too. You have to pivot on almost no notice sometimes, and so you don't really get to simulate that in education very often. So if you can think of how to do it, that would be cool.
Right. My final question is, if you could do high school differently, what would you do?
I think I would have been better about getting to know my teachers. I think a lot of the time I was shy to ask them questions, and I think I probably should have done that more, especially in getting prepared for college. You know, I wasn't one to want to ask the instructor for help or to ask the TA for help. So if I would have taken that step earlier on to get used to talking to people who had control over my grade, then that would have helped me a lot.
Perfect. All right. So now we have general remarks from the speaker. If you have anything else you'd like to say to students, to people thinking about this world, you know, it doesn't have to be long. This is more just to let Liam prepare himself for the next section.
Sure. I don't know. I think I would just, as a transition point, want to talk about how computer science is more than coding, and that there's a lot of things that you can do with it. Whether you decide to go into software and web and app development, or whether you go into something totally different, there's so many opportunities in cybersecurity or finance or robotics and animation and video games. I know so many people from school who became really excited about things that video game companies were building, or virtual reality, or Pixar. Like, there's so many things that you can do with computers, and they're everywhere. And so I think it's valuable to think about, to know that there's so many possibilities to explore there. This is just like one corner of the technology world.
Right, right. All right, Liam, so what I'm gonna do is turn the sound down on the TV and just have it come through my laptop, so that you should still be able to turn your sound on and just fully on, so that it's more about what you can hear. Don't worry about what's coming out from my laptop. Okay, take it away.
Okay, so we have 4 questions for you. What is your favorite part of your job?
All right, my favorite part of my job. I really like the aspect of software where you get to interact with the users. Like, I think it's really cool to be able to show an instructor a thing that I built and them have be like, oh, that's so cool, that's exactly what I needed. Or to be able to talk to them about problems they're facing and think about solutions. I love that part of being connected to the user and being able to help them.
Okay. What is your job security like? For example, getting replaced by someone that might be better, or machines?
Yeah, that's a good question. I feel very secure in my job, in the sense that I don't think that robots are going to replace software developers, mostly because you need software developers to build robots. There was a trend for a little bit about self-writing code, like being able to automate parts of your job. So in that sense, it would be cool one day if I have to write less code, but that also means that I better understand what it's doing if I didn't write it. So yeah, I don't think it's computer scientists or software developers are going anywhere anytime soon.
Okay. What is the biggest challenge you've had to get past in your workspace?
Probably one of my biggest challenges has been, we talked a little bit before about negotiating with managers or people who hold budgets. Sometimes there's competing priorities between the development team and the people that fund the development team. And so that's been challenging to kind of bridge that gap. And, you know, the only solution you really have there is that you have to take the time to understand each other and to communicate well. And that's kind of the best you can do. You're going to run into communication problems in whatever field you choose. So it's important to practice those skills when you can.
Okay. And what was your favorite project that you worked on?
So I think the project that I'm working on now is probably my favorite. In software, something that doesn't happen very often is you don't get to start from the beginning. A lot of times you inherit a piece of code and you just kind of have to figure out what's there and learn it. The project that I'm working on now, we got to start from the very beginning. So in some ways it kind of feels like my baby, because like I got to be there for the beginning of it. But it's a tool that we use at Purdue. It's called Variet. I actually can share my screen and show you a little slide. Maybe not. I'm not allowed to share my screen, Josh. Can you help me? Okay. All right, I'll show you this one. Okay, can you see that all right?
Yep.
All right, so this is our little logo thing for our tool called Variate. And what it does is you have an instructor. Let's see if I can do my little drawing. Yep. You have an instructor over here that creates a problem, like a math problem or an algebra problem. Think anything in your physics or your biology or math class. And then they create variables in that problem, so every student gets a different version. So Variate is this kind of randomizing tool that if the instructor chose a variable, it replaces it with different values for different students. So everybody gets a different problem. So we got to do it from the ground up. And it's cool because on the back end, we get to play with C# and with Python, which we don't use Python very often, but it's fun to do math again that I haven't had to do for a long time. And then it's just got a really cool interface on the front that is really easy to use and fun. From my perspective, at least, I think it's cool. So that's one of my favorites.
Okay. What are some of the other projects that you've worked on?
Sure. Some other things that I've done. This is my first job out of college, but in college I got to do a lot of different things. I worked in a chemistry lab for a while. That their job was to use the supercomputer on campus to do chemistry, and basically it boils down to a lot of math, but I was able to, simulate a molecule moving around. So that was kind of cool. I worked at a company called Thermo Fisher for a little bit. Thermo Fisher, if you had to get a COVID test, then they probably made the thing that you spit into a tube or whatever version of test they're doing. They probably made it. And so their job is a lot of manufacturing of biology related things. So my job there was, if you work on a manufacturing floor, you may notice something that needs improving. Like if you put this machine closer to this machine, you can do something faster than having to walk all the way across the hall for, things like that are small improvements that add up if you actually do them. So Thermo Fisher wanted to build a database where they could keep track of those ideas and make sure that they happened. So that's something that I did for them. Yeah, so I've done a lot of kind of side projects like that.
Okay. How are your projects completed? Do you have like solo team or small team or like big group of people helping you with stuff?
Yeah, so I work on a team that has 6 developers and 1 designer. So we work all together all the time. I talk to them every day and we collaborate on things every day. So we're a very tight cohort of the 7 or 8 of us. And then there's other groups of people that we talk to on campus occasionally, but it's all teamwork.
You want to mute? All right. I'm going to bring up the volume there. Well, thank you, Lily. Thank you, Liam. That was awesome and super insightful, and yeah, I learned more about the software world. Lily, do you have any last minute things you'd like to say to a high school audience?
Well, I would say thank you for listening to me. I hope it wasn't boring. And then I would also say that to just not be afraid to try new things. You never know how things are going to work out. Computer science is really cool. It's not just ones and zeros, and it's not all guys in the dark with their hoods up hackers that you see in the media. It's not true. It's way more fun than that. There's some people that are like that though, and if that's what you want, then you can go for it. But totally up to you. Anyway, that's it. I'm excited for all of you.
Awesome. Thank you so much, Lily. Hope you have a great rest of your day.
All right. Thank you, guys.
Bye.
Bye.